Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a little Q&A button. Click on that, type in your question, and I'll get to those at the end of the session. If you're joining us on YouTube, just use the live chat function wherever it happens to be on whatever screen you're using, and I'll get to those questions and comments later on as well. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department. I'm starting my 10th year training and traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on. So I had about 30 different reps that I worked with, as well as the customers that they service and the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, became the default diag guy in the shop. So I always had the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bag. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience. So our topic at hand today is 48 volt mild hybrid systems operation and testing. And boy, that's a mouthful. But end of last year, I was researching battery charging and starting systems for a class we did last year. And I was surprised at how many vehicles that are out there that are these mild hybrid vehicles, considered these mild hybrid vehicles nowadays. So I wanted to dedicate a whole class just on that, because they are coming up. And actually, we'll see a little bit later, they've been around for maybe longer than you think. You may be driving one right now. You never know. You just might not realize it. So let's think about just batteries in general, right? So battery, of course, stores electricity and mainly used to start the vehicle, especially in these applications. We're going to see that sometimes the starter is only used just to start the vehicle the first time, and that's it. And then we have start-stop technology that's used with the mild hybrid system. So it's mainly just used to start the vehicle, run the 12-volt devices on the vehicle. Once the vehicle is running, it's going to supply the power to the accessories using the alternator or the generator. And there are three main types. There's our lead acid battery, which we're all used to, very, very common. Absorbent glass mat, AGM batteries, and then lithium ion batteries as well. Let's see, that's lithium iron phosphorus oxide. I think would be what that LiFePO4 is. But it's a lithium ion battery. So lead acid batteries use lead plates and a bath of sulfuric acid. The difference in lead compounds transfers ions between the negative and the positive plates, and that gives us our voltage protection. So voltage per cell, when you measure the cell, should be about 2.2 volts on a good, normal, fully charged battery. AGM batteries use a similar system to the lead acid, except there's absorbent glass mat in between those plates. So the mats absorb the electrolyte and it avoids spill. So if I tip it over, I don't have electrolyte spilling out of the top of the battery like I may on a traditional lead acid battery with the caps on top. Maybe something pops off, something drains out. Keeps it from doing that. So it's going to absorb the electrolyte and make sure we don't have any spills of the acid. And then we get to our lithium ion battery. So this is what the heart of the mild hybrid vehicles we're talking about today will be using. So these lithium ion batteries use lithium ion technology and run commonly at 48 volts DC. There's some that are 48, some that are 42. I've seen, there was one I was looking up today, it was 36 volts, but it runs at 42 volts. So it's a 36 volt battery, but for some reason it runs at 48 volts. But they're used in those mild hybrid vehicles that we're talking about today. Now, mild hybrid vehicles give a small assist to the engine, increases miles per gallon. Also, a couple other benefits we'll talk about along the way as we go. But this was the main driving force behind manufacturers going with these mild hybrid vehicles when they first started was, well, we have mandates now where the fleet of vehicles that the manufacturer builds has to meet a certain average miles per gallon, what have you. So some of these vehicles, they need that little boost, and 2, 3, 4, 5 miles per gallon might be all they need to bring that average up a little bit. So there's more of these out there than you might think. Just put it that way. So they use a hybrid style generator to charge at 48 volts DC. So if we, there's a couple different ways, a couple different technologies that the manufacturers use right now. One kind of looks like an alternator, it's just maybe a little bit bigger. And it's actually used to charge the 48 volt battery. And it's also used to start the engine when we do start stop at a light, or so it charges and it starts the vehicle. And then there's another type that's actually more like a hybrid vehicle where it's got the stator generator inside in between the transmission and the engine. And then that is used to charge and start the vehicle as well. So by 2025, they say, this is from Delphi. So by 2025, one of every 10 vehicles sold worldwide will be a 48 volt mild hybrid. System will increase torque by more than 50% for faster takeoff and assist car companies with fuel economy and emission standards compliance, much like I just said a little while ago. The big thing with the torque, faster takeoff, is because what's an electric motor is just instant torque. As soon as you turn it on, the torque is there. There really isn't much of a torque curve, so it helps them smooth out the torque curve of the internal combustion engine. Another benefit on vehicles, say, that have turbos, on a standard turbocharged vehicle, we don't really have to deal with that turbo lag because it'll give it the power off the line, the electric motor will. And then by the time the turbo comes online, we don't have that noticeable lag, and it's just very smooth, very, very smooth takeoff. Uses a DC to DC converter as well. Sometimes we have a 12 volt battery to charge. Sometimes it just runs a 14 volt system throughout the vehicle, and it just comes off of that DC to DC converter. So as you said, a 48 volt system. It's designed to support heavier load components like the air conditioner and the engine fan to enable faster heating of the cabin and catalytic converter at startup. So there are, when I was researching this over the last weeks, there's most of these have electric water pumps, just right off the go. Most of them have electric water pumps. There can be even like an electric turbo. So those are available. I don't know if anybody's using them yet, but there are electric supercharger turbochargers. You can see down here on the bottom on the right hand side there. Those are available. Almost always electric water pumps, almost always electric air conditioning compressor, just because it takes that load off the engine, and that helps increase the miles per gallon as well. So there is also an electric catalytic converter heater that runs up 48 volts. Once again, haven't seen that one out either, but they may be out there, but I haven't seen one. Like you said, more power for takeoff, right? So the 48 volt battery can supply more power to the hybrid motor and the supercharger, launching the car faster and smoother than a traditional 12 volt system while saving fuel. 4 times the power enables an intelligent driving experience, improving efficiency and providing power for more accessories, such as active safety and connected entertainment systems. And then power from the hybrid generator via the 48 volt battery keeps the 12 volt battery charged as well. And then we may have an electrical distribution center. This is kind of just a high level generalization of what you might see on a car. We're going to go a little bit deeper into a couple different manufacturers here in a second as to what they do. Also, battery management. So even on a 12 volt system, 48 volt system, full hybrid, full electric, they have battery management systems. They use sensors, controllers, and software to monitor the battery's state of charge. And they can then adjust the charging rate of the battery depending on the load and the state of health of the battery. So when a battery is replaced, oftentimes you need to reset that battery management system as well. And usually that's with a scan tool. You need to do some sort of a functional test, reset, relearn. So let's look at a couple different manufacturers. So first is CDJR, so Chrysler, Dodge, Jeep, Ram. These are showing up on 1500s, the Ram 1500s, and also the Jeep. I think the Grand Cherokee and the Wagoneer are using these as well. So it has a battery pack in the back, and then of course we have our high voltage lines, and then we have a generator sitting in the front of the engine right there, and it looks just like an alternator, just a really big alternator. So you can see this is the starter generator assembly. This is on the 5.7 liter Hemi, so this is optional on the Hemi for most years, and then this is on the Pentastar here, or the 3.6 liter engine. 3.6, it's kind of mounted backwards, so it's mounted more to the on the front of the vehicle or the front of the engine, pointing backwards. So you'd see that the belt, you have to actually take this off to change the belt. So what it does, let's get a little closer look on the Hemi here. So what it does, you see it's a really wide belt. It's almost like a supercharger belt. on there. It's not grooved like a supercharger belt, but it's big fat belt. So it's used to charge, because we have the all the electronics package up here where it would do the charge from battery management system. So not only does it charge, but when we do stop start, which these vehicles have, so it's stop at a stoplight, the engine shuts off. When it's time to start the engine again, this goes in and it uses the torque of the pulley to start the engine again. They say it's a lot smoother than just using a starter, and you don't have to worry about a starter possibly wearing out in that particular case. So from what I've seen, most of the vehicles that do use the mild hybrid have that stop start, and that's how they do it. They use the generator as a starter as well. And Chrysler, Dodge, Jeep, Ram, whoever call this e-torque. That's their little branding on it. That's what they call it. So the e-torque system automatically stops and starts the engine when certain conditions are met to improve fuel economy and lower carbon dioxide emissions. The e-torque enable and disable selection switch is integral to the transmission shift. So it's a little button on the shifter. The battery starting and charging systems operate in conjunction with one another and must be tested as a complete system. So remember that. Must be tested as a complete system. For correct operation of starting and charging systems, all components used in these three systems must perform within specifications. When attempting to diagnose any of these systems, it's important to keep their interdependency in mind. So they're all intertwined. And if one little piece goes, it can take down the whole rest of the system and just not work until you fix that problem. Certain starting system components and functions of the e-torque system are onboard diagnostic monitors, so OBD2, and will produce diagnostic trouble codes. The use of the diagnostic scan tool is not only recommended, but it is necessary for proper diagnostics of the e-torque system and the components or systems that are related to e-torque system functions. Review the component and system information listed below in the operations section for diagnostic information. Otherwise, review the wiring diagrams as well as the DTC-based diagnostic service information. So the e-torque system uses a high torque electric 48-volt motor to function as a starter for electric stop-start. The e-torque system, when active, will shut the engine off with a signal from the PCM when the vehicle stopped, then start the engine when there's a demand for power. The e-torque system utilizes its own contained cooling system as well. For more information on the cooling system, look at that article. The vehicle's first engine crank event is managed by the driver starting the vehicle normally with the key or the start-stop button. During the initial start, the BCM cranking relay is open and the PCM cranking relay is closed. When the engine is on and the engine cranking phase is ended, PCM cranking relay will then be opened and the BCM cranking relay will then be closed. So the PCM controls the starter generator, the BCM controls for the regular start. All the next automatic e-torque cranking events managed by the same key on ignition cycle are performed, maintaining the BCM cranking relay closed and setting closed the PCM cranking relay. Each time an e-torque cranking event occurs, which causes the engine to run again, PCM cranking relay is open. Go down a little bit. So it's a motor generator unit is what they call it. So the 3.6 liter has a liquid cooled motor generator unit. The MGU as a hybrid control processor integral to the MGU is not serviced separately and must be replaced as a unit. It's over $1,000 for the at list for the motor generator assembly, everything. Let's see, power pack unit as well. So the power pack unit is a 48-volt battery pack with an integrated DC to DC converter and battery pack control module that supplies voltage for the electric stop-start system to start the engine during an electric stop-start event. 48-volt battery can also supply voltage to the 12-volt system when needed by way of its internal 48 to 12-volt DC to DC converter. The PPU on the vehicle is air-cooled using an internal dual fan assembly that circulates cabin air through the PPU. A dual fan assembly is serviced as an assembly with the PPU as well. So if the fan fails, you got to replace the whole assembly. It's 12-volt and 48-volt connection to it allow for the charging of the two different voltage systems. PPU is only serviced for replacement as an entire assembly. Let's see, starter motor. So this is what I found interesting. So this was the first system I researched. So the starter motor is only used once per ignition cycle. That's it. First time we start the truck up, and that's the only time that starter is used. So after the initial start of the motor generator unit, it's responsible for all engine restarts during stop events in that ignition cycle. So if I'm trying to diagnose a no start on this vehicle, I need to know which time is it not starting. Is it not starting the first time? Probably more than likely that would be your failure, right? But is it starting and then when I do start stop, it doesn't work? So if I do start stop and it doesn't work, then I know I have to look into that generator assembly, the motor generator assembly, Otherwise, if it's on the first start and it just doesn't crank, or it just doesn't crank, then I have to look at the actual starter motor itself. So you just got to wrap your head around how it's kind of, how they're interrelated to each other. So here's just that overview schematic, right, that we looked at before. So here's the motor generator unit up front. Then we have the wiring harness there, and then the power pack unit in the back. So the 48-volt battery is behind the back seat, and you'd access it through the cabin on that. So you see, it's not a ton of wiring. It just kind of goes up to the front to the motor generator unit. But this is an assembly. And then all the wires are still bright orange too, just because it is higher than 12 volts. 48 volts. It's not as high as, like, say, a hybrid or an electric vehicle, but it's still higher voltage than we would be used to. So you just do want to take the same type of precautions. Next, let's look at Mercedes. So Mercedes kind of does this a little bit differently. So they call it EQ boost. And what it is we have this stator starter generator assembly here in between the engine and the transmission. So what they call EQ boost, one of the biggest things I noticed in this diagram right here is a beltless engine. So they do not use belts on the engine. They just rely on the starter generator unit to start the vehicle. And then the air conditioning compressor is electric. The water pump is electric. Everything on that engine that would normally be run off a belt is all electric. So you just have to be aware of that as well. There's also a near engine mounted catalytic converter, but this is a turbocharged vehicle. So the what I was talking about earlier, where it helps with turbo lag. So when it cranks when the engine starts up and you start going, it will give that instant torque that an electric motor will give, bypassing, kind of smoothing out the turbo lag that you would normally be worried about waiting for a turbo to spool up. There's a little closer view of it in the vehicle. So the control modules here on the side, you can see there's some coolant connectors as well as the electrical connectors. And then it's in here. It's like a stator ring assembly. It's both a starter and a generator, depending on what mode the vehicle's in. So if we look at to generate drive torque, one of the following is used: only the combustion engine, only the electric engine, or the electric machine in combination with the combustion engine in hybrid mode. In hybrid mode, the electric machine and combustion engine work together on the powertrain, which aggregates the torques of the individual drives, and it knows when to turn it on and off and ramp it up and ramp it down. So it gives a really smooth takeoff. So the control of the hybrid system comprises the control of the combustion engines and the control of the power electronics control unit with the electric machine. The master control unit is thus the powertrain control unit, which contains the aggregate coordinator and thus coordinates all torques in the hybrid system. The top objective of the control is the lowest possible fuel consumption. So there we go, trying to get that miles per gallon higher. The energy management also takes place with the powertrain control unit. So it determines the required output of the electric drive for the relevant vehicle data and requests this from the power electronics control unit. So as I said, it manipulates the torque and the speed of that drive unit in order to smooth out that torque curve, reduce the amount of fuel being used. And then we get to GM. GM is actually one of the OGs with these systems, and I probably should have started with them first, but they've been using this mild hybrid technology for longer than you might think. So they call it eAssist on their vehicles. So it consists of a power pack, which is like this, with the integrated electronics as well. So there's 32 cylindrical lithium-ion power cells, and there's all the electronics to run it, all built into this one power pack, which is usually in the back of the vehicle in the trunk. And then we have a 15 kilowatt motor generator that goes on the front. So they use a very similar type system to how Chrysler Dodge Jeep Ram uses it. So here's just a layout on one of these engines. Is a V8. I think this is the 5.3. They actually use this in pick-em-up trucks now. So it's got the starter motor generator there. And then you see we have a lot of belt tensioning going on because it has to use that belt to crank the vehicle over. And then we have the battery power pack. And then there's a service plug there. And then, of course, the power that goes to it. Now, by the way, these are all three-phase electric motors too. So just so you know, a lot of them run on AC and then they convert it to DC. But it is a three-phase electric motor. So you're not just testing one thing, you're testing three different phases. And as I said, it's been around for a while. way back in 08 with the Malibu. And actually back in 07, they had it on one, I think it was like the Saturn Vue. But Saturn Vue, I don't think they sold a ton of those. But 2008, the Malibu. And then generation 2 of the system began in 2012 with the Buick LaCrosse, the Malibu, a couple other sedans. And then their third generation with this, the Ecotec motor right here. And then that's the LUK engine code, by the way, if you're into that sort of thing. But you can see there's that starter motor generator right there, and that's able to crank that engine over. A couple, the AC is being run by it too, so it's not an electric AC on that particular vehicle. But you notice I don't really see the water pump anywhere unless it's integral in there. I suppose it could be. But like I said, most of these types of vehicles have the electric water pumps. And then Gen 3 began in 2016 on the Sierra and Silverado. They have a 5.3 with a certain VIN code that has this type of system on there as well. It's got the motor generator unit on there, and that's used for the start-stop system, off the line takeoff, that sort of thing. So they've been out there for a while, and they're probably in your shop whether you know it or not. Because I mean, how many 08, 09, 2010 Malibus are out there? Probably quite a few. And then Buick LaCrosses too. So there's plenty of these out there, especially when you look at GM. Nowadays, like 2022, 2023 vehicles, you got them on pickup trucks, both Ram and Chevy. Ford's starting to use them in their vans. Sedans for GM as well. A lot of those are using it. Mercedes we saw, BMW, Audi, Volkswagen. Hyundai likes it. Kia uses it as well. Honda uses it sometimes. Toyota uses it sometimes. So they're definitely out there. And they're a little bit different the way you work on them. It's a lot of scanner work, not so much with the scope work, even though the scope could handle the 48 volts because it's rated for 400. But it's just certain different ways you need to test it. Most of the time, you're going to be checking resistances from what I was seeing in there. So let's look at a couple of these on the tool. All right. So first one I got up is the Mercedes that we were looking at earlier. So it's a CLS 450 is what it is. And let's look at a little bit of the repair information we have on it. So I'm going to put in the generator here. And we can see specifications, testing. So testing, how am I going to test this? So what they want you to do to test it is you're going to use a ohm meter, and you're going to check what the resistance is between your different phases. So this actually has 6 phases. So you have UVW and XYZ. So there's multiple sets. There's also a set gap between the stator and the rotor that you can measure as well, 0.9 millimeters on clearance. So any of those can be measured. And if we want to look at the picture of what that looks like, it's down here. So we got UVW and XYZ. So it's got 2 sets of 3 windings on it. So you can actually pop the cover off and check that per their instructions. Right? We want to be careful with that. So coil connections damage, the overall resistance will increase or decrease. The measurement values lie outside of the tolerance, replace the whole darn thing. I got that in parts and labor. I don't remember if I looked that up. Yeah, we don't have parts for it, but labor is a 4-hour labor to remove it and install it. We don't have a parts for that right at the moment. Remove and replace, though, it's going to give you some of your things that you need to do. So let's see, control unit. So as we can see, we have on the side here that's called N129 is what they call the module. That'll come into play later. See how we got multiple electrical connections here, and then 48-volt wiring harness there. All right, brackets, starter generator, control units in there, and then inside is the actual unit itself inside of the transmit, like the bell housing. All right, here's another better look at it with the cap off. You can see where the plug goes in and where it wires in. We can look at the wiring diagram here in a second too. See if they got any other pictures. They got a whole lot of there's a special tool to check the gap, and then there's the stator right there. You can check the gap in there and check where we need to look. There's a good amount of information on that. And then if we go to wiring diagrams as well, so it pops up automatic AC first because that runs off the alternator too. We have the charging circuit here. So this is Starter generator control unit, that was on the outside, right? And then we have the actual integrated starter generator. So there's no color assigned. And it's 1, 2, 3, 4, 5, 10 different wires going to it. It also has a regular battery, just your usual battery, but it does not have a starter in this case. So this vehicle, the way they run this is that starter generator control unit is what starts the car. It doesn't have a separate 12-volt starter for the vehicle. So that's good to know. If I'm working on this, I don't want to look if it's not starting. Like that scenario I said earlier, if it's not starting, in this case, we have to look at that starter generator control unit in order for that to happen. All right, so that's the Mercedes. Let's go in and look at. Oops, I wanted to go back there actually. We'll look at the scanner on that as well. So for scanner functions, you see we got our usual suspects, engine, transmission, etc. But I got to go all the way down here to hybrid vehicles. We got battery management system, charger, starter, alternator, 48-volt electrical system. Simulator on, so it's going to ask me a few things. So you get codes, data, functional tests, and under special functions, there is also a teach-in of, remember how I said that was called the N129, starter alternator control unit. So when I replace it, I got to relearn it to the system. So you can actually go in there and click on that. It'll walk you through it. I get an error inside the simulator, but you would be able to walk through that. Just follow the instructions and it'll allow it to relearn when you replace the unit, if you replace the unit. Hopefully you don't have to replace the unit. All right, let's go to our RAM. In here, look at the same type of information here. So just call it Bighorn. Okay, and then look up generator again. So we got the generator and we got the high voltage battery. But once again, we got the wiring diagrams in here, and there's your charging circuit with the eTorque system. So you can see it's got a regular battery, and it's got an intelligent battery sensor on there as well. Powertrain control module, and then we have the generator unit module, which is integral to the generator motor unit. And then we have the 48-volt battery pack as well in there. So 48 volts in, crankshaft signal, CAN bus, we got a little bit. So that is our starter generator unit right there. This one, I believe, does have parts. Yeah, so it's 2.6 hours because that's the one that goes the wrong way on the front. So there's a little bit of bracketry to take off. $968 at list to replace that one, 3.6 liter engine. So it's about $1,000 for an alternator, generator, whatever you want to call it. Component operation is going to tell us how it works, right? So we have the description here. See a couple of the different components mounted on the vehicle there. Instrument panel, a couple modules there. And then if we pull up the wiring diagram, I just think I just did wiring. Yeah. And then if we go over to our scanner again. Wait for security link. Okay. There we go. It is behind security because it's a 2020. So then we come down here and we got the battery pack control module and the hybrid control process. Go in there. Some functions in there. Got a battery isolation test, got an ECU information, enable and disable high voltage battery contactors, reset high voltage impact events. So if it has a collision, you got to reset the system there as well. You have to reset or replace the module too. There's some things you can do in there. So a lot of different functions you can have, plus as well with your data. If you want to be checking your data, you can see the different voltages in there, coolants, different cell voltages on the batteries itself, temperatures, etc. So based on what the manufacturer says you need to pick up, you can see that different data that you might need. And then we also have the hybrid control processor. So that one's also going to have a couple functions in there. Belt capacity adaptation resets. I think that I don't know 100% if this is correct, but I believe you would have to do that under if you replace the belt, because that sure sounds like that. So belt capacity adaptation reset. Actually, no, it says run this procedure only if you get these 2 DTCs. Okay, so I was wrong. So resets the internal hybrid control processor counters are required to clear these DTCs. So if you do get either of those DTCs, though, you got to do that functional test. And I can't do it because I'm not hooked up to a car, but you would have to do that. And then once again, there's some data in there as well. Different supply voltages, inverter temperatures, different currents, say a phase UV and W on this one. So there's a lot of information to be had in there. Like I said, a lot of it will be done with the scan tool in order to check that. And then the last one we'll look at is the, where we got? I guess I got a Malibu in here. I didn't have that labeled. But, there's some more scanner things we can do on this Malibu as well. So there should be. Nope, not on that one actually. So I picked the wrong vehicle, but they are available on the Malibu for sure. Let's see if I got a different one. Nope, I think I must have deleted it by accident. So yeah, there we go. A couple different examples of things that you can do. A couple wiring diagrams. You want to make sure you understand how the system works. Which type of systems does it have? Does it have the integrated one that goes in between the engine and trans? Does it have the one that's like a giant alternator on the outside? 48 volts, so you just gotta be aware of that. So just trying to give you a high level overview of what you may be dealing with out there, because like I said, they've started since 2008 on GM vehicles. They've been using them, so they are definitely out there, and you are probably seeing these in the shops as well. So just wanted to make you a little more aware of what's going on with these systems. So that is my time for today. Let's talk about next week, what we're going to talk about. So this is the 5th class in this series of 5 classes. So we are through the new classes, and we're going to start the repeat of the 5 next week. So the power of experience-based information. We'll talk about what have others done in this situation? Why do I want that information? And what kinds of information can I get from this massive database that we have of information? So same time, same place as usual, 6 and 9 Eastern. You want to join me on Zoom at snapon.com/OT. On 6 p.m., we go live to YouTube as we're doing right now. So it's youtube.com/Snap-on Diagnostics. If you are watching on YouTube, I'd appreciate it if you'd subscribe and make sure you hit the like button, ring the bell to get all your notifications anytime we go live or post new material. Once again, it's youtube.com/Snap-on Diagnostics to check that out. And then we also have past previous topics in this series are also available on our YouTube channel. So there's a playlist for live training. So anything from ADAS down to testing intermittent electric faults, which we did last week. And then this will be episode 62 going up there right now. It's being recorded as we speak. We're doing it right now. So if any of these look interesting to you, hey, it's free. 62 diagnostic training classes, all about half hour or so long, maybe 40 minutes, for free. Who else does that? I don't know if anybody else does that. So that's pretty cool how we're able to offer this, I think. So with that, come join me. We do have Q&A. I got a couple questions on both, but before I do, make sure you also look up my friend Keith here. So Keith also does diagnostics training for free, but it's on Scan Tools. So on Wednesday, it's on Zeus, and on Thursday, it's a combo Apollo and Triton class, because the scanner on the Apollo and Triton are the same. So the first half of the class is going to be the same. One time a night, so 7:30 Eastern, 6:30 Central on Wednesday and Thursday. Go to snapon.com/OT to register and hold your seat there. Helps you walk through some of the functions of the tool. First thing is, let's get you set up on Wi-Fi. Make sure you get set up free Snap-on Cloud. We'll talk about security link and all that. Then he walks through code to completion, a scenario on Fast Track Intelligent Diagnostics. And then after about a 5-minute break, he'll go through the scope and meter functions on the tools as well. So make sure you double check that out. If you want a little bit more training on your scan tool, or you're just interested in learning more. All right, let's get to questions. I got one on Zoom here. Let's see. I missed the first hour of training. Well, you missed the first half hour. So this is, as I just said there, Sandeep, it's being recorded to YouTube, so you can definitely check that out in probably I don't know, it usually takes half an hour to an hour to process, but once it's up there, it'll be on our YouTube channel. Otherwise, there's another class at 9 p.m. Eastern. If you're in the Eastern time zone, I'm not sure what time zone you're in, but there is another presentation of this live tonight as well, if you want to see that. So thank you for that. Over to YouTube. Quinn, welcome. Thank you. So I see you do have a question. Let me get to that in a second. Maurizio, welcome. Thanks for joining us. And then Anthony, great presentation, more than just mildly interesting. Yeah, good. I always like a good pun. Quinn also says, ouch, $1,000 for an altar. So let's see. Oh, Quinn's got a long question here, so I gotta read it. Just try 10. Calibration, which is different. Can fill the shocks on an aromatic system, but I've not been able to do the calibration, which is different. 2010 W212 E550. Had to borrow somebody else's tool to do it. So let me just look. Since I have a minute or two, just take a look. Put that up in the simulator, which is not always 100%, but at least get an idea. So 2010. $212. One of these. I'm just going to pick one. Probably not that one. Say a 550 is probably not that one. That might be a 5. All right. And then we go down to suspension. So there's going to be two different suspensions in here. So that one doesn't have it. Key off on the Mercedes. We don't. Yeah, so depending on what it is, so there's a couple different modules in there. Let's see. Filling, pressure relief. It's going to depend on what module it has, I guess. So it does the fill, it does the release. I do not see calibration on that. Pick a different one. There's a level calibration on that one, but that's that particular variant. So it depends on what variant of suspension they have in the vehicle. Mercedes get a little complicated with that. You could find, as you saw, there's probably dozens of different variants on there. So it does it on some of them, not on all of them. Best thing I would ask you to do is let me know if you have the VIN of the car. If you have the VIN of the car, and send it to me and just let me know you wanted to recalibrate the air suspension. I can have them look into it and see if maybe it's just one of the variants we don't cover and we need to get it in the software. So if you could do that, if you could get the VIN, my email address is jason.cabrinas@snapon.com. It's pretty easy to remember there. So if you want to just shoot me an email with the VIN and the specifics on the vehicle, if you can, that would be appreciated, because they're not going to do anything without a VIN. But I can at least run it up the chain and see. So with that, it's like we got all the questions. Thank you very much for joining me. Thank you very much for taking a little bit of time out of your busy day to spend a little bit of time with me. Hopefully you learned something about these 48-volt mild hybrid systems that are out there, more prevalent than we may have been aware of before today. So definitely thank you for your time. Enjoy the rest of your week. We'll see you next week for our experience-based information. That's the one. See you next week for that. Enjoy the rest of your week. Enjoy your weekend. Have a great night and take care.